I'm talking about securing the Internet of Things. I'm talking jointly with Paul Madsen. Unfortunately, Paul was indisposed, so he tweeted this yesterday. A little bit unfortunate. This is unfortunately going to colour my view of the Internet of Things and OAuth for the future. Every time I think of it, I'll think of this rather unpleasant tweet. So, never mind. I thought I had an About Me slide. Yes, I do have an About Me slide. So, Paul works for Ping. I'll give him some credit since he's helped me. We discussed this. He works for Ping Identity and is one of the leading people on OAuth and OpenID Connect. I'm the CTO and co-founder of WSO2. We're an open source middleware platform. Can I just do a show of hands? Has anyone heard of us before? Oh, good. That's better. The last presentation I did yesterday, there was nobody put their hand up. So this is an improvement. I'm also doing a part-time doctorate. I'm looking at security, and so that's part of my interests. Been working in Apache for about 14 years now. Been a committer on a number of projects and PMC member and sponsor of some incubator projects and so forth. And I work on SOA stuff initially, APIs, cloud. I participate in some of the MQTT working groups, and I've been increasingly doing more things with the Internet of Things. So the first thing is, does security matter? Do you really care if somebody knows how many steps you've taken that day, for example? I thought this was a quite nice Dilbert cartoon, which illustrates it. I actually think it matters a lot, and I think there's a lot of personal data involved in IoT, and I'm going to sort of give some examples of that. And I think one of the things is that we want these devices to monitor our lives and participate in our lives. And I feel that the NSA knows enough about my life already. We've just found out in the UK that the NHS has been selling our personal health data to insurance companies and researchers and various other people. And they actually have a plan to just sell it to anybody who asks for it. So I think it does matter. This was there's a free paper in London, and about a month ago, the free paper handed out had this on the front page, a fridge full of spam. I thought there was a joke. It turns out this is a real story. So a researcher chased up a whole bunch of IP addresses where they were getting spam email from, and tried logging into these email addresses and actually logged into this fridge that was sending her spam. Because it was a Linux system and it had an open SMTP server on it, and they were just using it to redirect spam from their fridge. Pretty interesting, kind of cool. I'm sure you all know about Google hacking. Google hacking is where you find a particular search string which helps you identify a device that's open. So these are search strings that help you find people's webcams that aren't protected. A particular researcher found a Google search string that gave them about 60 hits, which was a smart home automation system that had an open web interface on it. They logged into those, and out of those 60, about 20 had identifiable information in them. So they actually phoned these people up and started saying, I can switch your lights off, which is kind of scary. These devices, they're not internet connected, but these are devices that improve your home automation, improve your house heating system, and they use completely unencrypted radio communications between them. So, there's nothing to stop you if your neighbor annoys you and you happen to know they've got this, basically increasing their heating bill by transmitting random stuff. This device, if you don't know what it is, I'm not going to explain it to you. But this is a device that uses exactly those same unencrypted radio waves. And somebody used that to create a new interface to it, very creative. You can read more about it. I didn't include the original title of the URL because that was itself quite interesting. There's somebody who makes an internet-connected version of this device, and they when interviewed about security, they were like, well, I don't mind if I get extra ones. So, but it's very personal data being captured here. So I think the reality of this is that we need to care a lot about internet and security of the Internet of Things. So then the question comes, well, what's different about the IT? I mean, there's lots of areas in life where there's poor security. There's lots of web apps that have poor security, lots of people getting hacked, like Adobe recently. So lots of areas have poor security. So what's different about the IoT? And I think there are two aspects. I think there's still all the same cloud and web system aspects. Most of these devices connect to some cloud system. So there's all those aspects, but then there are new aspects that are brought in. And one of those is that we're embedding any security information into these devices, and we expect them to last a long time. We don't expect to have to take our device and somehow reprogram it with an update. And even if we do, it's unlikely that's going to happen. Those smart homes that were hacked I just told you about, they'd released a fix, but nobody had updated their systems. And that was a fairly easy, it had a web console, and you could have done an update quite easily. If this is some small embedded, Fitbit or something, it may be much harder. The size of the device is important too. For instance, cryptography is tricky on Arduino devices. So this is an 8-bit Arduino. It's tricky to do it. I'll talk more about that. The fact there is a device, so there's not, a lot of the security models we have today are things like you type in a user ID and password. In these cases, there's no place to do that. The data, we've already talked about how it's personal data. Maybe your health data. It may be whether you're at home or not. It may be to do with, all sorts of personal things, aspects that are now being managed and monitored by devices. And I have nothing against appliance manufacturers, but they do what everybody does when they're faced with a problem, is they just grab something ready built that's usable. So quite often they grab a chip, or they grab some source code for that chip, some ready-made C code they find. I mean, it's exactly the same as web designers who go and Google. I mean, it's the same problem exists on the web. If you say, how do I add user authentication to my PHP app? The top hits on Google are all giving you bad advice. Well, if you go and grab the simple radio chip to build your device, it's the one that has no encryption, no security, and let somebody update your heating bill or give you unexpected pleasure. So I think one of the things we have to do as a community is to try and improve the stuff that's out there that they grab, and that's going to be one of my messages for today. I think we have a responsibility to try and create better archetypes and exemplars. So let's just talk about physical hacks, because that's one of the aspects of this. This is the card that gets you around the London Underground. And it's based on a thing called MyFair Classic, which was made by NXP. And some researchers, the first lot of researchers, Noel and Plotz, actually took the thing apart and scanned it with an electron microscope and reverse engineered the code of it. Some follow-up researchers, a guy called Flavio Garcia, then cracked the encryption code and demonstrated he could travel for free on the London Underground. NXP tried to actually quash this and stop them publishing their paper, but they took it to the court and they got free speech. So there's an example of someone who had taken a bad algorithm and they'd relied on obscurity. They'd relied on the fact they thought, well, no one's going to do this. Somebody did do it and figured out how to hack it. There are companies out there, there's quite a lot of them on the web, who offer to do this for you. This is a company who will take a device with a chip on it and unlock that chip so you can read the code on the chip. There's a web page saying how you can do it yourself by blasting your Arduino with high voltage. I don't know if that's safe or not. I'm not recommending this to anybody. If you burn your house down or fry your Arduino, that's your problem. There's a nice academic paper going through a number of options of how to do this. The same thing happened with the Xbox. People figured out by fiddling with the power supply, they could switch off locking bits on the chips. So the hardware is a challenge here. So, the only recommendation I have for you is don't rely on obscurity. Let me be clear. Do not rely on obscurity. This is a common thing people do. So what does that mean? I guess that means the most important thing is that unlocking a single device should only risk that device's data. So in other words, you shouldn't build a system that relies on some key that's embedded in the device that then if you get that key, then you can read everybody's communications. So that's a really important hardware point. Now we talk about the network. And the biggest problem with the network is crypto on small devices. So this device has an 8-bit AVR chip on it. AVR make a crypto library, and to get the equivalent of 2048 bits of RSA key length, it takes this device 1,600 seconds to do a simple signature. So that's not going to be, in my view, very likely that your device is going to go away and sit, locked out for that long. Seems like it's highly unreliable, and most device manufacturers would say, don't be stupid. This is quite a good paper, by the way, if you want to understand this. However, there are some better libraries, and ECC, and they've done some optimization that show that you can do stuff on an 8-bit chip. So this is some various libraries. That AVR crypto lib is only 3.6K, so it's nice and small, but not efficient. The tiny ECC library, with some compiler optimization that they did to it, showed that you could do in about 3 seconds the equivalent of a 1,500 bit RSA using elliptic cryptography. So that's possible, but still unlikely on this device because it's taking up half of my available memory, half of my available ROM for code, and just I've never seen anyone actually do it in real life. So it's theoretically possible, but not done much. I thought this was another good Dilbert cartoon. I didn't actually make those numbers up, they were real, so that was nice. This is a nice chart from a guy called Chris Swan, which he presented at QCon in London a couple of weeks ago. And it basically identifies some issues. The biggest issue in this small device is the RAM requirements for those crypto libraries rather than the ROM requirements on the speed of the processor. Of course, now we're getting Arduinos that have ARM-based chips in them, and the problem there is just the availability of good libraries and cipher suites, and we're going to talk about key distribution in a minute. And of course, things like the Raspberry Pi and the BeagleBone and the Arduino Yun do make this quite achievable and quite easy because they're just Linux devices. They're equivalent to your normal computer. So I guess you might ask me, isn't ARM and Atheros and these kind of things just going to solve this problem? Why should I care about it? If you don't know what an Arduino Yun is, it's a nice device. This bit at the bottom is a traditional Arduino with an 8-bit controller. That bit at the top is a single chip Wi-Fi that you'd get in a cheap Wi-Fi router, and it runs Linux. and it runs a distro called OpenWRT where you can update the distro. So effectively you've got a full Linux machine and you've got a embedded chip for connecting to your systems. That's quite useful because actually some embedded applications don't run very well on Linux because it's not real time. So you can actually put all the real time stuff on the 8-bit microcontroller and put your other stuff on the Linux chip. So this might solve the problem, but I still think cost matters. You know, if you're a device manufacturer, you typically go for stuff that's really cheap. You know, if it costs an extra $20, it changes your economics massively if you're selling this device for $50. The Raspberry Pi has a $25 retail price, but only because they make them at basically the scale of mobile phones. They've made, what, 1 million of them now. And they've managed to keep the price really far down. They've taken no profit at all. So I don't know what the embeddable price of that device is, but I don't think it's very different. Whereas you could buy an Arduino for £3 off eBay, including shipping. The price to embed that same technology into your app, into your system, is less than $1. And when this thing gets down to be $10, you can bet that thing's going to be less than 10 cents. So I think the economics does matter somewhat. Of course, in the very long run, you know, in 10 or 15 years, it's not going to matter so much. There are other options. There's a crypto chip from Atmel that does elliptic curve cryptography on the chip. Costs about 50 cents a piece. No one has yet built a Arduino shield that embeds this. I think that would be really useful. The shield itself would probably still cost quite a bit, but then if it was an open source hardware circuit, what would happen is that then when people came to, you know, they'd prototype with Arduino, and then they'd take that and embed it into a thing, and the whole cost of the unit when they came to mass manufacture would be much cheaper. And that, to me, is one of the things about Arduino, is that the open source nature of the hardware has meant that it's been a great model for prototyping stuff that can then be, you can then refactor that. You don't have to take that exact board shape and build it into cheap stuff. I know a guy in the UK who's built a really nice modular synth by doing that, for example. There are some lightweight block ciphers recently released called Simon and Spec. The only problem is that the people who released them, the NSA, have a program called Bull Run, and Bull Run is their stated aim is to make sure that all the ciphers that are out there are no good and can be broken by them. So it's unlikely these are going to be particularly secure. We talked about TLS earlier in the previous talk. Julian mentioned. There is evidence you can do DTLS in a small device in about 16K of ROM and about 4K of RAM. I think that backs up what Julian said. It's not particularly simple and lightweight. On the other hand, you know, that's an acceptable price to getting cryptography and UDP. The other big challenge here is the key distribution. If you use, for instance, the pre-shared key that Julian was recommending, that means that every device has to have either has to have a key on it, or you run that risk that someone breaks that one device and they get the key to everything. So you now have a problem of key distribution to these devices. You generally have a problem with key distribution to devices anyway, because keys expire. You don't expect a key to have a 10-year lifetime. So there are challenges there. So I mentioned before, I think we need some exemplars for good ways of doing security, good ways of doing these things. I think it'd be really nice to have, like, for instance, a ready-built firmware for Arduino Yun that embedded, you know, a good security approach, a good approach to key distribution, a good approach to cryptography, a good approach to authorization and authentication. I think it'd be good to have an Arduino shield that did the same thing. So this is my kind of challenge to the community to make some of these things. We heard about constrained application protocol in the last talk, and the Californian project. It doesn't have any authorization or authentication in the protocol itself. So you either need to use DTLS, which is really about encrypting, or you have to put something in the body. I think that's actually a bit of a weakness. I think one of the best things about HTTP is it had an extensible header for authorization in a standard place, and I think CoAP really misses out with that. I'm not going to go into a lot of detail on MQTT. There's been lots of good discussion about it today. If you don't know it, some people have some nice stickers saying MQTT inside. If you've got Facebook on your mobile phone, then you've got MQTT inside your mobile phone because all the Facebook apps use it to communicate. So this is actually a very widely deployed protocol already. Of course, has lots of good traction in Eclipse. The Mosquito project and the IBM donation of the RSMB to Mosquito is good. The Paho libraries, and of course now Moquette is joining as well to create a Java implementation. So very, very, very wide set of clients and servers. MQTT relies on TLS for confidentiality. That is definitely a challenge. So I'm going to show you a demo of using OAuth on an Arduino, and I completely fudged it and avoided the TLS, which is a huge security flaw. So that's a bit of a challenge I think we have to address. And it has a username and password field for authentication. Passwords suck. They suck for humans. I've spent last 10 years working with things like the OpenID Foundation trying to get rid of passwords. I think we're finally getting there with OpenID Connect and with OAuth 2, which are finally solving that problem in the web. But if they suck badly for humans, they suck much worse for devices. Devices should not be using usernames and passwords. They're things you're meant to memorize. They're not things that you're meant to embed in somewhere. So what's the answer? The answer is tokens. So the idea with a token is that a token has some limited ability just to do something. You don't share your password with the person who needs it. You just share a token, and they give you some ability to go a little way. Probably the best example of what a token is this thing. You've probably all got one in your pocket right now. This comes from Tim Bray, who works for Google, and is a nice, I think, probably the best human analogy for what a OAuth 2 token is. It's basically a time-limited token that gets you into your hotel room. Doesn't matter if you lose it, because they can revoke this one and issue a new one. Doesn't matter if you walk away with it at the end of the stay, because the day your hotel room expires, the token expires. And it doesn't get you into other people's random rooms. Instead, it just gets you into the room you deserve to go into. So it's a very useful concept. And I don't know if you know this, but so we've been through a sort of a bit of a journey here. What happened was we initially had a spec trying to get rid of passwords called OpenID. When Twitter started implementing it, they realized that they weren't really dealing with a human login issue. They were dealing with a machine-to-machine login issue. They were trying to solve the thing of how can I enable another web app to post on my behalf. So they realized we needed a new model. They came up with this thing called OAuth and proposed that to the IETF. That then went through a second iteration and became OAuth 2. And then in a sort of circular, weird way, people started thinking, well, actually, I have a federated access control mechanism, but I can use that as an identity mechanism. Because if the only person who can get into your hotel room, or or sorry, the only person who can issue a token to get into your hotel room is you, then if you issue someone a token and they go into the room and they look and there's a big sign saying it's Paul Fremantle's room, they know, well, that must have been Paul that gave me that token. So they sort of circularly took this thing that was designed for authorization and turned it back into something that was designed for authentication. And the OpenID Connect standard was formally ratified and launched 2 weeks ago, but it's already in heavy use by people like Google and Facebook. And these two standards work together very nicely to create this federated identity system. So I think federated identity is a really important model for the Internet of Things. And why is that? Well, firstly, I don't want my device, I just want that device to just have enough permission to do what it needs to do. And secondly, I want any other people who are reading that data downstream in the cloud or on the web or through an app website to only have enough permission to get just enough permission to do what they need to do that I want them to do with my data. So that's an important aspect. I think it's also even more important that in the long term, I would really like my devices to be able to work with multiple providers. So the idea of federation as a whole across the IoT is also important, and I think that's why MQTT is such an important standard, because if we move to a model where these devices are using standard protocols, then I'm not locked into the provider who sold it to me. It starts to open up. The OAuth 2 has really been used mainly for web, but there are... Oh dear. I forgot to screw this in. There are examples of using it for non-web stuff. For instance, there's a... Oh, let me just... Sorry. Let me go back. So there's a spec... Sorry, that shouldn't say SSL, that should say SASL. I think that's an autocorrect problem. SASL is an authentication scheme for binary protocols, and there's a spec called Kitten, which uses OAuth 2 tokens with that. So I'm sure you've all probably used OAuth 2. This is an example. If you see a web page like this that says, this website would like access to these things and it's not going to get access to those things, then that's an OAuth 2 flow. So this is really nice. I would like this. Like if I have some smart home scales, I would like to be able to say that yes, I would like to share my average weight over the last month with my diet club, but I would not like to share it with my mother, my potential girlfriends, sorry, I'm married, I shouldn't say that, or my health insurance company. So, you know, these are exactly the kind of things I think we should be doing around IoT. So, you know, what is it? It's firstly much better than a password. It's revocable and it's granular. And there are these two different aspects that I think are important. So device to the cloud, saying we're going to put a token in the device and make it revocable and manageable, and then from the cloud to some other app saying, you know, who can now access that data elsewhere. For some reason I've got the same information twice. I think that's one of Paul's slides and one of my slides. I didn't merge them. So I've done a demo with MQTT and Arduino, but it's not really just for MQTT. It's just a proof of concept that this concept can work. And I was using it to explore, you know, what can you learn from doing this? And I actually learned some interesting stuff by doing this, so I think that was good. So what are the demo components? There's quite a lot going on here, but let me try and simplify it. So the first thing is there's something called an identity provider, and in this case it's my server, something called a WSO2 identity server. It's a good Eclipse citizen. It runs as a set of OSGI components running on Equinox. And there is a one of the things that's important in OAuth is look at the token itself, but you often need to go and say, what's the validity of this token, what's the scope of it? OpenID Connect makes that all part of the token by using something called a JSON Web Token. But in standard OAuth 2, you don't necessarily have the ability to look inside the token. So there's something called an introspection API. And that is standardized by the IETF. Well, it's not standardized, there's a proposal from the IETF. Unfortunately, our identity server doesn't yet support that. We're adding that in. So I put a little plug-in to do that. So the first thing that's going to happen is I'm going to create a token by asking the identity server for token. And then at some point later, that token's going to be handed over and said, is this token valid to do this? What's going to hand it over? Well, I've got Mosquito, which is this Eclipse project. It's a MQTT broker. And that's going to be publishing, people are going to be publishing and subscribing to different topics on here and asking for information. And every time they do that, there's a plugin here that's going to go and say, well, you've got a token. Does that token give you access to that topic? So that's all cool and very simple. But there's one more little wrinkle here. With OAuth 2, there are actually two tokens. You get an access token, but that has a short lifetime. That only lasts, say, a day or an hour or whatever. And then when that expires, you're meant to refresh it. How do you refresh it? It's a web protocol. So you make an HTTP call to the identity provider and say, I want to refresh this token. You get a new access token. Sounds fine, doesn't it? Except I've already got, so on my demo here, let me just show you this. Oh, just lost my battery. Let me unplug it quickly. So this is an Arduino. This has got the controller on it. It's got 32K of ROM on it. This is an Ethernet shield that gives it the network connectivity. And on top of it, I've got a little accelerometer. So I'm going to be collecting my data about how much I move and so forth. The problem is that the Ethernet and MQTT code takes up about half of my 32K. The accelerometer code takes up the other half. The whole thing takes up 97% of the ROM, and that was after I mangled it a bit. It took up 103% to start with. So I don't have any room to do any HTTP code. So I wanted to say, okay, well I want to do that refresh flow via MQTT as well. That way I'm not reliant on this. And this is the same message we just had from Julian. Just one protocol makes life easier. So what I do is the Arduino comes along and it says, I've got a token, and the Mosquito says, I'm sorry, your token's not valid. So then it disconnects and it reconnects to a different broker, really. I didn't do that, but it should be. It should be a different broker, and it says, I need to refresh my token. And it passes over the refresh token, and then I have a little bit of Python that picks up that refresh token, goes to the identity provider, swaps it for a new access token, hands it back to the Arduino. Now the Arduino can disconnect again and reconnect with a fresh access token. And it can also blat it into its EEPROM and save it for next time. So that's the whole flow of what's going on here. So let me see if I'm a CTO, which means I'm a pretty poor programmer. I used to program, but then I got promoted. So these things are slightly flaky. So let me plug in my thing here. So and also I'm a command line hacker, so my demos have a lot of command line consoles up and nothing much more. So right. So what I have here, let me switch to the right window. This didn't look good, did it? I didn't switch it on yet. So I'm going to switch it on, and there we go. So this basically is it saying I tried to connect, and I've made sure the access token is wrong. So I basically published a access token of 0, 1, 2, 3, 4, and it went to that through the broker, and that called out to the introspection and it said, sorry, this token's no good. So then it disconnected and reconnected here, and it went and the refresher gave it a new token. And then it goes away, and I put a little delay in here just so that I could talk for a minute. And hopefully in a few seconds, it's then going to reconnect, and now suddenly you can see my your pitch roll data as I move the thing. So now it's publishing to that particular target with a valid token, and it's accepted that. Let me just show you one more little bit, which is how did I get that token in the first place? And that, if I just go... So this is kind of nice. I have a command line tool, and it redirects me to a web page because I need a web bit for this part, because the way of the token is I'm not passing any of my credentials over to anything to do with this. I'm only talking to the IDP to get my credentials. It says please log in, and I log in as, well, let's do it as Paul and Hedgehog. And then it says the MQTT OAuth basically wants access to this scope. Now really I should have this as a nice thing. What happens is if you dbase64 this, you'll see that's actually a nice JSON saying I want to be able to write to the topic /pzf /your pitch role. The reason I base64 encoded it is that spaces mean something in OAuth scopes, and I wanted to use JSON. So they weren't compatible. You're meant to just use a string that means something. I thought it'd be nicer just to encode it as JSON and actually capture the meaning right into the scope. So, let me get my presentation back. So some lessons learned from this. You know, I mean, I guess we all knew, the minute I said OAuth and MQTT, one probably thought you could figure something out to make this work. I did learn something interesting though. I mean, firstly, just squeezing it on was really tight. The second thing that was interesting is the OAuth spec actually says that when you do this refresh flow, it may change the refresh token and pass a new refresh token back. That's an optional part of the spec. Now, I think that's a really bad idea when you have an embedded device. So that refresh flow is an HTTP flow. It's inherently unreliable. Now, if this is a web system, right, if you log on to Twitter stats, right, and then Twitter stats tries to refresh their token with Twitter, and it fails, and the next time you log on to Twitter stats, they say, I'm sorry, your authorization seems to have died, can you re-log in again? Right? No problem. If it's hard-coded into some device that's sitting in your house, you don't want to have to go through that. You don't want to have to take it to the repair center to have them flash a new thing into it, or go through some weird process to do it yourself. So I actually mentioned this to my product team, and they changed our identity server to let me turn that off so that we could have a consistent refresh token. So you basically say, we're going to make this token last for 20 years or the lifetime of the device until somebody actually explicitly revokes it. Another aspect is similar. The scope in OAuth 2 is the set of permissions that this token has. And again, most servers don't let you update the scope of the token. They kind of expect you to throw that token away and get a new token with a new scope. Again, that's not going to work in this embedded world. So the spec's kind of rather vague on this matter. It doesn't say you can, it doesn't say you can't. But again, we're going away and improving our server to let us update the scope of tokens in place and really treat those tokens as persistent long-term things rather than the sort of semi-persistent view we have of them today. Another thing we're doing is letting you back up those tokens so that if your server dies, you don't have to refresh them all. I mentioned that I went to the same broker for that refresh flow. That's a security flaw, but it's not really a big deal. It was just a implementation detail. And one thing I had to do was I had to send just this token to just one device. And MQTT doesn't have that in the spec. It's not, I'm not necessarily sure it should be in the spec, but I think there should be a well-known pattern for doing this that all the brokers support. Some brokers like RSMB supports this. I actually hard-coded a new, since I took over the authorization, I just hard-coded a new authorization rule to say if it has this topic, then it only goes to the thing. So this was a short presentation. I didn't really talk much about the cloud aspect of this. I think that's just as important, what happens to the data once it gets into your Xively server or your Fitbit server or whatever. But I think that's more of a standard problem. So I hope this has been useful. Quite a big overview. I've covered hardware, network, federated identity. What's my message? Well, think about security when you build devices. Think about security when you build cloud services. Try and use the very best practice, which are things like OAuth 2 and OpenID Connect. Don't just go Google, how do I add security to my PHP app, and the first thing it says is create table, create column, data, password, character 64. Do not do that. And participate in the community, and let's try and create some good exemplars, whether they're shields or libraries or server software or open standards on how to actually embed security properly into these devices in an easy way, so that when the designer in a hurry next has to create a device, he can go and find the really good stuff and use that off the shelf. And that's it. Any questions?
Some of these algorithms require time, and a lot of these devices don't have reliable stuff. Is that a challenge at all?
Let me repeat the question. Some of these algorithms and security things require time, and these devices don't have good clocks in them. That can be a challenge for replay attacks. That's usually the point where you need the accurate time in a device. It's not something I've looked at personally, but it certainly will be an issue worth considering. I think if you tend to get away, if you start using things like OAuth tokens and you say you have a client certificate and an OAuth token and you talk to the server the way like a web does, the replay attacks are less of a problem. It's really more of a problem when you have a predefined key that you're using and you just say, well, okay, I blap that message over and somebody can grab it and then replay it over and over again. I think it will be an issue for some devices, yeah. It's a good point. Right, I'm over time, so I apologize. If you want to ask me more questions, I'll be around and about, and thank you very much.